Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over part 1 of our AP Calculus multiple choice practice. Our focus on this clip is on differentiation techniques. All right, let's take a look at the first problem. It says if f of x is cosine the third power of 4x, then f prime of x equals. So this is a problem assessing ability to carry out the chain rule. Okay, we have a composition of three functions here, and we're asked to find what the derivative is. So let's go ahead and write this down. So let's say we have f of x equals cosine uh, the third power of 4x. So let's go ahead and write this as a composite function. So here we have three functions. So we can write this as f of, sorry about that, f of g of, let's see, h of x. F of g of h of x is equal to, I can rewrite this as the as cosine of 4x. Cosine of 4x is being raised to the third power. Okay, so the outermost function is your cubic function right there. All right, so what we're going to do now is we're going to proceed to decompose this function, and then we'll apply the chain rule in finding its derivative. All right, so let's start with the outermost function. We're going to extract uh, f of x. So let's put that to the side here. So we have f of x is equal to x to the third power. And then the inner function, let's pull that out to the side. The inner function cosine is actually a composite function. Okay, so the inner function is f of g is g of h of x. So we have g of h of x. G of h of x is what? G of h of x is equal to cosine of 4x. Okay, so we've taken out the outermost function, which is a cubic function. Now what we're going to do next is we're going to decompose g of h of x again. So this is g of h of x. So to decompose this, we're going to pull out, let's go ahead and pull out the outer function, which is g of x. So let's pull out g of x. So we have g of x is what? G of x is the cosine function, cosine x. That leaves us with the inner function, which is h of x, known as 4x. Okay, so all I've done just now is decompose this function in a way where you can basically see it. Okay, so when you compose these three functions, you end up with this composite function right here. Okay, so let's go ahead and find the derivative of the functions. So derivative of f prime of x, using the power rule, is 3x squared. Derivative of g of x, don't forget the negative is negative sine x. And then the derivative of h of x, h prime of x, is 4. Okay, so what is the derivative of a composite function? Let's go ahead and write down the formula first, and then we will apply it to this situation. So f of g of h of x prime, the derivative of that is what? It's basically f prime of x, the derivative of the outermost function, evaluated at the inner function, which is a composite function, so g of h of x, times the derivative of the inner function, which is a composite function, evaluated at h of x, times the derivative of the innermost function. Okay, so that's simply the formula for the chain rule when you have the composition of three functions. Okay, so all we're just simply going to do, we already have f prime of x. We're going to plug in g of h of x into x for f prime of x to get the first part. And then we're going to take h of x and plug it into g prime. Forgot the prime notation here. I'll take h of x and simply plug it into g prime of x multiplied by h prime of x4. Okay? And that will be our derivative. Let's go ahead and write it down. So our answer will be f prime of g of h of x is 3 instead of x squared is going to be 3 times cosine 4x square, okay, times g prime of h of x is for negative sine x, you just plug in 4. X for sine x, so negative sine of 4x. And then h prime of x is 4. Okay, so let's go ahead and make our answer pretty so we can know what the correct option is. So multiply 3 times negative 1 times 4, you get negative 12 cosine, and this is the format you write it, square 4x, okay, sine of 4x. So our answer for the first problem is option letter B. Okay, so let's make sure that's right. All right, let's take a look at the second problem. This is a composition of two functions this time. So we're going to be using the chain rule twice. But before we differentiate this, we just have to review a quick rule for differentiation. What is the derivative, ddu, of your inverse sine function? The derivative of an inverse sine function is 1 over the square root of 1 minus u square du dx, applying the chain rule, okay? All right, so let's go ahead and I'm going to do this using the approach I used earlier for the previous problem. F of g of x is equal to arcsin of 5x. We just have two functions here, okay? So let's take out the outer function f. So f of x is what? What is f of x? F of x is the inverse sine of x. Okay, that leaves us with the inner function. This one's pretty straightforward since you just have two functions. Inner function is g of x. G of x is 5x. So f prime of x, if we differentiate this function, we'll use this idea here, this differentiation rule. F prime of x equals 1 over the square root of 1 minus x squared. G prime of x using the power rule is 5x to the 0, which is just 5. So what is the derivative of f of g of x? If we apply the chain rule to this formula right here, to this function, this composite function, the answer is going to be the derivative of the outer function evaluated at the inner function times the derivative of the inner function. All right, so let's go ahead and apply this formula to the result we have here. We just take g of x and plug it into uh, f prime of x. That will give us the first expression times g prime of x, okay? So our answer, let's see what it asks for, dy dx. Our answer is going to be 1 over the square root of 1 minus x squared, but instead of x, we'll have 5x. So if we do that, 5x squared times g prime of x, which is just 5, multiply across, we have 5 over the square root of 1 minus 25x squared. So our answer is option letter, let's see, which one has a 5 on top? Oh, option letter E. All right, let's take a look at the next problem. It says for t greater than or equal to 0 hours, h is a differentiable function of t that gives the temperature in degrees Celsius at an Arctic weather station. Which of the following is the best interpretation of h prime of 24? Okay, so h is basically the temperature. Okay, so h of t is the temperature. Now, what is h prime? H prime is the instantaneous rate of change of the temperature. It's basically asking you at that instant in time, namely t equals 24, at what rate is the temperature changing? Okay, so h prime of t is dt, the instantaneous rate of change of the temperature at any time t. Okay, so using that idea, h prime of 24 is basically asking you for the rate of change, the rate at which the temperature is changing um, when t is equal to 24. So evaluate the instantaneous rate of change when t is equal to 24. So let's take a look at the options that we have right here. So change in temperature on the first day, change in temperature on the 24th day. These are just delta H's, okay? Delta H, delta H. These are just change. Average rate of change of the temperature during the 24th hour. Average rate of change basically is not the instantaneous rate of change. Okay, so average rate of change, basically delta H over some delta T over a time period. Okay, and then this is the rate at which the temperature is changing during the first day. For this one, this is the instantaneous rate of change of the temperature when T is equal to 1. Okay? It's close, but that's not what we're looking for. The rate of change, the rate at which the temperature is changing at the end of the 24th hour. That's what we're looking for. Okay? So ddt is the rate at which the temperature is changing, and then we fix it at the 24th hour. D is equal to 24. That's the correct answer. Okay? So you have to have rate of change at a particular time. That's the instantaneous rate of change or the derivative. All right? All right, let's take a look at the next problem. It says the function f is differentiable and has values as shown in the table above. Both f and f prime are strictly increasing on the interval 0 less than or equal to x less than or equal to 5. Which of the following could be the value of f prime of 3? So if f is increasing, that tells you that f prime is going to be positive, right? And if f prime is increasing, that tells you f double prime is going to be positive. If f double prime is positive, that means f is concave up. Okay? So in this problem, we're going to have f, we're going to note that f is increasing, okay? And concave up. It's concave up because the second derivative is positive, a consequence of the first derivative increasing. Okay, so f prime increasing implies that f double prime is positive, which implies that f is concave up. Okay, so that's the whole idea there. Okay, so with that in mind, how are we going to we're going to be making an estimation here. How can we determine the right value for f prime of 3? Now, what we can do here is we can get arbitrarily close to the instantaneous rate of change of the function at 3 by looking at the average rate of change at 2 points really close to 3. So what we're going to do is basically look at the average rate of change from 2.8 to 3, and the average rate of change from 3 to 3.1, and the instantaneous rate of change will be bounded between both of them because the derivative is constantly increasing. Okay? All right, so the inequality we're going to be using to bound our desired result is the average rate of change from 2.8 all the way to 3 is less than the instantaneous rate of change of the function at 3, and instantaneous rate of the change of the function at 3 is going to be less than the average rate of change from 3 to 3.1, because we know that the first derivative is constantly increasing. All right, so we just find these two average rate of change, and whichever value resides between them, that will be our answer. Okay. All right, so before we get started, let's review what the formula for average rate of change is real quick. Average rate of change on an interval AB is basically f of b minus f of a divided by b minus a. Okay, so that's what we're calculating. All right, so let's go ahead. So let me just give you a visual illustration as to what we're doing. So let's say you have a function that's increasing and concave up, okay, and then you have 3 points right here. So this is 2.8, this is 3, and this is 3.1. So what we're saying is that the slope of a secant line here is going to be less than the slope of the tangent line here, and the slope of a tangent line here is going to be less than the slope of a secant line there. Okay, let me color code it so you can see. Okay, so there you have it color coded. All right, so the red one, see this red one right here. This is the average rate of change from 2.8 to 3. Okay, the slope of that secant line right there, and then the green line, that's the average rate of change from 3 to 3.1. And then what we're trying to estimate or determine is the blue line. That's the instantaneous rate of change at x equals 3. Okay, so that's what we're trying to bound with these two values. Okay, so now we have the formula and a visual. Let's go ahead and find out what the average rate of change are. So a rock of from 2.8 to 3 is simply f of 3 minus f of 2.8 divided by 3 minus 2.8. Okay, and then now you use your table to find out what is f of 3 and f of 2.8. F of 3 is 45. 2.8 is, what is 2? F of 2.8 is 39.2 divided by 3.8 minus 2.8.2. This is the calculator active part of the AP exam, so you can use your calculator to compute it. You get 29. And then you do the average rate of change from 3 to 3.1. The same procedure. You have f of 3.1 minus f of 3 divided by what? Divided by 3.1 minus 3. And then you carry out the computations using your table. You have 4.8, 48.05 minus 45 divided by 0.1, and you're going to end up with 30.5. So what's f prime of 3 going to be? We know that f prime of 3 is going to be between 29 and 30.5. So 29 is less than f prime of 3, and f prime of 3 is less than 30.5. So let's look at our options here. 30 is our option. Option letter D is the correct answer. All right, let's take a look at the next one. It says the table above gives values of differentiable functions f and g and their derivatives at x equals 1. If h of x equals 2 times f of x plus 3 times 1 plus g of x, then h prime of 1 is. So this problem is assessing your ability to find the derivative of a product of two functions, namely the product rule. Okay? So we remember what the product rule is. If you have a product of two functions, let's change the color here. I'm going to use blue for that. Let's say we have u times v, and you want to find the derivative of u times v is simply vu prime plus uv prime. You can write it in reverse order since addition commutes, okay? So it doesn't really matter. In this problem, we have h of x equals 2 f of x plus 3 times 1 plus g of x. So we'll simply find our u and v function and apply the product rule, okay? So this function right here is our u, and this function right here is our v. So if we apply the product rule, we're going to have v, which is 1 plus g of x, times u prime, the derivative of that, we just find the derivative of these two functions. That's going to be, let me put it in blue. If you differentiate that, you have 2 f prime of x, derivative of 3 is 0. Okay, so that's the derivative of u, that's u prime. So we have v u prime plus, now we're going to do uv prime, all right? So u is 2 f of x plus 3 times v prime, the derivative of that, derivative of 1 is 0. Derivative of g is g prime of x. Okay, so this is our derivative at any arbitrary x value. Now let's go ahead and fix our derivative at 1. So what is h prime of 1? You differentiate first, now we're going to evaluate, okay? H prime of 1 is simply going to be 1 plus g of 1, okay, times 2 f prime of 1 plus 2 times f of 1 plus 3 times g prime of 1. What did I just do? I simply plugged in 1 for all the x's. Now to finish it off, we just simply consult our chart to figure out the values of g of 1. This is g of 1, f prime of 1, g prime of 1, and f of 1. Okay, so we just put in those values. Use your table to find out what the value of each of these functions are. If you do that, you're going to have 1 plus g of 1, which is negative 3, close that, times 2 times f prime of 1 is negative 2, plus 2 times f of 1. F of 1 is 3, plus 3. G prime of 1 is 4. Okay? So that's what you have. And then just use order of operations to simplify this. We have negative 2 times negative 4 plus 2 times 3 is 6. 6 plus 3 is 9. 9 times 4 is 36. And then minus 2 minus 4 is, minus 2 minus 4 is positive 8 plus 36 is 44. There is your final answer. Option letter D. Okay, so that's that. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found this clip to be helpful or beneficial, do give us a thumbs up. We'll appreciate it. Do not forget to subscribe to our channel for updates to the remainder of this review series. If you have any questions concerning this video or the AP Calculus exam in general, just post a comment in the comment section below, and we'll be glad to address it as soon as possible. More clips can be found on mathgotserved.com under AP Calculus. Thanks again for watching and have a wonderful day.